This is a lesson on designing labs. There are many steps to do in designing labs. First thing is to identify what you're trying to find out. Identify or state your purpose or question, whatever it is that you're needing to look for. It has to be clear, complete, P-L-E-T-E. And if you have variables, they have to be identified. If you're doing a lab where you're trying to find a relationship between the variables identified, if you're just trying to find the identity of something, you do not need to identify the variables. Background information. On background information, it's just a short paragraph. That's a symbol for paragraph. On what you already know. You already know about the subject. It can be common knowledge stuff. It can be stuff that we've studied in that chapter. Right hypothesis. Remember to use the word because. Most of the time, that's the easiest way to get it in if you use the word because. You don't have to do that way. To design your own thing, what you got to do is you got to go backwards. You got to figure out what your results are, what you need to find out, and then from that, what calculations you need, if any. And then from that, you can figure out what data, what information you need. So you can set up a data table. Planning a lab is going to be kind of backwards from when you write it up. What data you need depends upon what calculations you are going to do, what formulas you have to get the results. So reverse in your procedures, you're going to find data, calculate it, then give the results. But to plan it, it's easier to go backwards. Results, and then what calculations you need to get those results, and then what information or data you need. Important that the data table contains observations only, no calculations. Only. No calculations. Calculations are in a separate area, separate result. Write a proposed procedure. This is your plan. You got to come in with a plan. Clearly identify the steps needed on how you get the data to fill in the data table. So on a proposed procedure, you need, it's an idea, it's a plan. So it's a plan, clear steps, on what you need to do, on what is needed to fill the data, on what is needed to get, needed to be done. To get the information for the data table, to fill data table. It is useful to maybe pantomime this. Use hand gestures, like actually fill it out, pouring things out. And that will also help you out. Pretend like you have a beaker in your hand. Pretend you're putting a thermometer in the solution. Pretend you're measuring out recording masses. And that will help you when you get to what materials. What materials do you need to are needed to do the procedures? If you're going to heat something up, you got to tell me what you're going to heat up, what you're going to use. If you're going to weigh something, you need a weighing tray. If you're going to record a volume of a liquid, you need to have a graduated cylinder. Things like that. So any possible materials you might need to do the procedures that you do, you write them down. So what is needed to do your plan. Here's where the pantomiming will be very helpful. The only thing you really don't need to write down for materials is water. Assume that we got water there. Safety. You write down, this is the catch-all phrase, usual safety precautions are taken. Precautions were taken, and if there's anything that was special, like strong acid, note that there's fire, heightened glasses, things like that. But any special issues, so usual safety precautions are taken, and any special issues. Then you do the lab. You actually go ahead and do the lab, perform it. And as you're doing the lab, you update your procedure. If there's something that you didn't think of that you're doing, add it or drop it. So you update your procedure as you go. You might have to add steps or drop steps, switch. If you had them in reverse order, add equipment, lab materials as you do it. The final report shows the actual. Final report must tell what really happened, what was actually done. So what was actually done in there? Results. When you're doing results, show one sample calculation. If you have 4 or 5 or 6, you don't have to do all 4 or 5, but show one sample calculation. If you're only doing one calculation, then you just do that calculation. You can have a results table to show all the other values that you come up with. Do the results support hypothesis? If you had a hypothesis. Support hypothesis. So you should have a statement to there. Restate the hypothesis, and is it supported if you have one? What else could be done? Be studied. What improvements would you throw in? What other things you could do? And then, so what else could be done? What improvements? Or what other concepts or things? You notice that something off the track was interesting, you might want to do that. And then communication or discussion. This is either sharing what other groups had or writing sharing with and from other groups what their results are, or it involves answering questions in the book. This is a quick thing on how you design your own lab. It is involved, and it's kind of confusing for a while. I got a handout for you that I'll include on the notes with this. And we're going to spend several days doing this. This ends this lesson on designing labs.